My name is Joseph Cassidy, and this is my Engineering Design 496A presentation for the midterm project. Recording this video, I'm using Cam Studio. It's an open source video recorder that can be downloaded at camstudio.org. During this presentation, I'm going to be using task-specific terminology. That means I'm going to look at it, and basically what it does is what I'm going to call it. So this is the first part I designed, and it is the screw of the 3-hole punch. To design this, I used an extrude to create the round feature, and then a cut to create the feature that allows a screwdriver to screw it in. To create the thread, I used a simple sweep of a thread line. I used another sketch here to give me the pitch of the screw. I then implemented equations into each of the dimensions of the pit of the screw and made them all relate to this line here, which I dimensioned as the pitch. The next part I designed was the guide for the cylinder. The cylinder runs through the middle, then actually cuts the paper and is screwed into place at its back. To design this, I just did a extrude square and then cut out the necessary pieces along one plane. I only designed half of it and then mirrored it to get the full effect. To make the thread of the guide, I made an assembly of the screw and the cylinder guide, and then converted the geometry of the original thread of the screw so that all the equations would stay in it, made a new helix, and then cut right out of the guide. This makes sure that the screw will always fit perfectly into the guide. Next, we have the cutting cylinder and the cap of the cutting cylinder. To keep them separate, when I revolved the cap, I didn't click the merge result button, so I would have two different solid bodies that I could save separately. The cap snaps into place, and because it's made of a plastic material, it would deform enough that you could actually snap it into place. We also see a notch here around the middle of the cylinder. This is used for the spring ring, which keeps the spring in place and allows the 3-hole punch to do its job. This is the spring that goes around the cylinder. I made it using 3 sweeps. One sweep on the top plane, one sweep on a new plane that I made, and one sweep using a helix spiral of the bottom. This is the spring ring that goes in the indent of the cylinder. To make it, I used a extrude and then cut out the profile of the cut that I needed. I then filleted the edges to give it the same appearance as it has in real life. Here we see the top of the 3-hole punch. To create it, I used the symmetry of the object to only design half of it and then mirrored it across the right plane to produce the rest of it. I then shelled out the back of it to create a uniform thickness of the entire plate. And on the front we see a decal that I added to make it more realistic. To put that in, I used the PSUSolidWorks decal property, found their logo online, copied it to my desktop, and placed it on the front at about the same position it would be found in a real 3-hole punch. Here we see the bottom of the 3-hole punch. To create the ruler on the bottom, I used a linear pattern so that I only had to draw the first inch of slots, and then I could pattern the rest of it along the face of a new plane that I made that cut the bottom of the 3-hole punch. I used the hole wizard also. I created a sketch to make sure that my geometry was correct and then made a hole that fit the geometry. Here we see the hole collector of the 3-hole punch. I used an extrude with the draft feature to get the draft that ultimately makes it connect to the bottom of the 3-hole punch. I then shelled it out to create a uniform thickness and used the extrude thin feature to create each of the lines on the inside of the hole collector. This is the connector that connects the bottom of the hole punch to the top of the hole punch. It would be inserted through this hole here. Then a machine would push this end out, thus creating a connection that doesn't require a screw, nut, or bolt. And finally, we come to the washer that would be placed in between the screw and the bottom. It's just a washer. One of the challenges I faced while designing this product was showing the knurling on the top of the screw. While SolidWorks does have a stainless steel knurled effect listed, for whatever reason it doesn't actually use it. To get around this, I just used a checkerboard configuration to show that a knurling effect would take place there. Another interesting challenge I faced was the design of this spring ring. Initially, I thought it was just a washer with 90 degrees of it cut out, but when I finally got the cylinder away from it, I realized that there was an interesting configuration and not what I originally thought. This design allows 3 points of it to touch the cylinder, get into that groove, and also allows a machine to just press it on versus having to actually bend it on. One of the software limitations that I found while doing this project was while I was trying to engrave the numbers in the ruler in the bottom of the hole punch. Once I had a number of the numbers done and dimensioned, it became increasingly slow, as you can see, because of the large number of sketches and dimensions required to make everything fully defined. A good example of converted geometry can be found in the bottom of the hole puncher. These sides are nearly the same but differ by this little notch, which allows the paper to be longer than the actual hole puncher. I first designed this piece, this side, and then needed to design the second side. Instead of drawing a whole new sketch, I converted the arc top and the side from the old geometry and then completed the sketch. It was then self-defined, and any changes made on the right side of the bottom would then be immediately correlated to the left side of the bottom without a user having to add any extra features. An example of the on-edge sketch can be found in Extrude 6 of the top of the hole punch. After I mirrored it, I needed to create the geometry of the top of the hole punch. To do this, I sketched along the edge of the top for 3 sides and a small portion of the 4th side, and then connected them. This required much less geometry than it would have if I would have defined each feature separately and not used the on-edge geometry. There are some ways that this design could be improved or refined. One way is for this guide, cylinder guide, to be formed out of a sweep instead of the numerous extrudes, cuts, and single mirror. It could be swept using a number of guidelines and pathways. Also, this spring could be done in a single sweep instead of numerous sweeps using 3D sketches that would include the helix top and bottom. Also, the bottom has a number of sketches that are included only for their geometry. These could be added to other sketches to reduce the length of the design tree.